Good afternoon. Welcome to Go Beyond VFP SQL with SQL Server and MySQL. I'm Tamar Grainer. In addition to being one of the organizers of this conference, I've been writing and speaking about FoxPro and Visual FoxPro since the late 80s. Helped to write a number of books. Actually wrote one of them all by myself. And just have been involved in all kinds of community things for a long time. Much of my work is with other developers, and I'm always interested in hearing about new opportunities. Here's what we're going to do today. We're going to talk about several problems where you can do them in VFP, mostly using a combination of SQL and X-based code, but SQL Server and to a lesser extent MySQL offer better ways to do them with language features that VFP doesn't include. We're going to work today with a sample database that is not one you may be familiar with, although I've used it for this stuff before. It's called Chinook, and somebody created this so that you could have the same database to use across a number of SQL engines, which makes it easier to do comparisons to see how things work the same and how they work different. It didn't have a VFP version. I created that one, and the downloads for the session include the code to generate the database. It's a database for an online music sales system, so it has artists and albums and tracks, and they have genres and playlists, and then the usual invoices, lines, customers, employees, things like that. In this session, some of the time, we will not look at the VFP example. We'll look at most of them, but I'll skip some because mostly they're things you could probably figure out on your own, and because I want to spend more time in the other SQL engines. So the first problem we're going to talk about is consolidating data from a single field. And the slide shows an example. The question that we're asking here is, for each track in this database, what are all the playlists it appears on? And the results here are a little strange because whoever created the sample data ended up creating multiple playlists with the same name, or a whole lot of them just called music. But the basic idea is that you're doing aggregation and you have some field where you don't want to add or get you don't want to count or sum or anything like that. What you want to do is you want to create usually a comma separated list. It could be separated by something else. And so that's the question is, how do you do that? Well, in VFP, the answer is you do the query and then you loop through the results to get what you want. So here's the example. We run a query where we go in and pull the name and ID of the track and the name of the playlist. So we get all of them. We get all of them. We're going to have one record for each combination of track and playlist. And then we create a cursor to hold the results. And we start at the top of the cursor we already created, the one from the query. We grab what is the ID of this track, what's its name, and we initialize the variable C playlist to the empty string. And then we just loop through that cursor. If we've reached a new track, put a record into the result cursor with the track ID, track name, and the list of playlists that we've built. You haven't seen it get built yet. And then update those variables. Update the track ID and name. Clear the list of playlists. And then, whether or not we're on a new track, add the name of the playlist that we're currently looking at to the list that we're building. And the first part here is just if we're starting with Nothing. If we have the empty string, just make it empty. Otherwise, add a comma and a space. And then at the very end of the loop, we're still holding the last track. So go ahead and insert that one, and then we'll go ahead and browse the result. And we get results that are like what was on screen. We'll track names are very long in this database. So I'm going to pull. I put it in a memo because if I don't, I don't know how long it could be. Okay, that's not hard code to write, but it's tedious. In the SQL engines, each of them has a function that does this job. We'll look at MySQL first, where the function's name is group concat. So here's the query. Again, we choose the track ID and the name, but then we call the group concat function, and it accepts this sort of unusual parameter, the field that we want to concatenate, and the order in which we want it. Since we only have one field here, order by one makes sense. Put the playlists for this track in alphabetical order and concatenate them. And by default, it'll concatenate them with a comma. And the only other thing that's different than the original query in the FoxPro side is we are grouping on track ID and track name. I'll try not to highlight too much here. They're changing the highlight colors in MySQL Workbench turned out to be non-trivial. But we're going to group on the track ID and track name, and then we'll put the whole list in order by the track ID. And not surprisingly, when I run this, we get exactly the same results, except it's not using it. We can see this last field. So that's group concat. In SQL Server, the name of the relevant function is string ag, and it has an even stranger syntax. You pass the field of interest or the expression of interest. You pass the separator you want, here a comma. But then you have to say what the group is, how to group for that function. So we say within group, and then in parentheses, order by playlist name. So it's got a little more syntax, which the rest of the query is the same. We'll see something with a similar structure later in the session. And when we run this, again, not surprisingly, we get the same results. I'll note that string ag only came into SQL Server in version 2017. So for older versions, there were not long-winded, but long-winded solutions. I'm not going to cover them. And arguably, they're not really better than the FoxPro solution. This session is an update of a session I did in 2014. The paper's on my website. If you're stuck in an older version of SQL Server and need to know how to do this, you will find the solution in that older paper. Are there any questions to this point?
No questions.
Okay, thanks. Okay. Let's talk about self-referential hierarchies. What do I mean? In the database world, we work with hierarchies all the time. We're forever looking at invoices that have lines, and lines have products, and products have categories, and so on and so forth. But those are all different tables. But we also work sometimes in situations where we have data in a table that refers to other data in the same table, and an org chart for a company is the classic example of that, or where we might have a couple of tables that refer to each other, something like a bill of materials, where there are different ways you might structure it, but the bill of materials has product, and that product may contain some assemblies, but an assembly is kind of a product and contains other products, and you have to drill down. So in Chinook, we have an org table. This is the org table for Chinook. And there are some questions that we might ask about hierarchical data like this. For an org table, these are questions that I can imagine wanting to know the answer to. Who manages a given employee? For a given employee, what's the entire management hierarchy? That is, who is their manager and who is what I've heard called their skip manager, that is their manager's manager, and who is the person above that person and the person above that person, and so on, all the way up to the top of the company. So given an individual, what is their hierarchy of managers? And then the flip question, given an employee, who are all the people that employee manages directly and indirectly? So who do they manage? And who do the people that employee manages manage? And who do those people manage all the way down to the bottom? And those are the kinds of things we might want to know in a hierarchy of this sort. So how do we do it? Well, traditionally, the data would be, at least for something like an org table, in a single table. In the FoxPro Northwind data, it's the employee table, as it is here in Chinook. And there is a field that points to that employee's manager. It's called reports to, both here and in Northwind. This is a really easy way to populate this data. To populate for a given employee, you just need the primary key for their manager. But some of the reporting we want to do is kind of hard in this situation. So let's take a look. Not surprisingly, some of the time, we're going to end up using a combination of SQL and XBase. But let's start with the simplest question. Who manages this employee? And it turns out that the query is exactly the same in all three of these databases, except for where you put semicolons, because that differs. Semicolons are terminators in the SQL engines and continuation characters in FoxPro. But the way we do this is by using what's called a self-join. That is, you open the same table twice and join it to itself. This is the equivalent in VFP of saying, of opening a table again with a different alias. And you actually specify what we call a local alias in the query itself. And you can actually put the keyword as in between if you want. So what we're saying here is open employee once, call it emp. Open it again, call it manager, MGR. Do a left join between those two instances based on the reports to field of the employee being equal to the employee ID of the manager. Go out, match one employee to another on one employee's reports to field being another employee's employee ID. In other words, find the manager of this employee. Here, we're going to do it specifically for employee 4. We could do it for the whole set. And what we get is that Margaret Park is managed by Nancy Edwards. And as I said, it's the same query in all three. This is really straightforward, not hard to do once you know about self-joins. But the other two problems aren't that simple. We'll start with the easier of them, which is what is the management hierarchy for a given employee? And in VFP, we're going to do that, as I said, with SQL plus XBase. Although it's not a lot of SQL, to be honest. We're going to create a cursor to hold the result. We're going to open the employee table. And we're going to grab the ID, the employee ID that we're starting with, and we're going to count levels here. We're going to give the employee we're interested in level 1, their manager level 2, and so on. And then we're going to do a loop until the ID of the person we're the current ID we're looking at is empty. Find that person, insert into our result the first name, last name, and the level. Then set the current ID, the one we're interested in, to the reports to field of that. In other words, to the ID for their manager. Increment the level, go back and do it again. We're going to do it over and over till when we get to the top, current ID will be 0 because the person at the top doesn't have a reports to. And then we'll look at the results. Oops, except I wrote this as a function, right? I have to pass in an employee ID. So we'll do it for employee 3. So Jane Peacock is managed by Nancy Edwards, who's managed by Andrew Adams. And I could do it again, but different one. Okay. In the SQL engines, we're going to use something called a CTE, a common table expression, that's going to allow us to do this much more simply. And we're specifically going to use something called a recursive CTE. But we're going to first look at a CTE. Many of you may be familiar with the idea of a derived table. That is a select in the from clause of a query, where you can say select some fields from this table, join, and then inside parenthesis, another query. A CTE is similar to a derived table. I think it's more readable, though, and it gives us some flexibility that derived tables don't. So let's go over to SQL Server, and we're going to look just at a simple example of a CTE. What we're going to get here, and we could do this in a single query, but it's a good example, is we're going to get the sales by year for each track. So the syntax for a CTE is it starts with the keyword with, then the name for the CTE, then in parenthesis, the list of fields, the keyword as, and then the CTE itself between parentheses. And the CTE is just a query. So let's actually highlight the part that is the CTE. So we're saying go in, join the invoice to the invoice line, get the track ID, the year of the date, sum unit price times quantity, how much did we make, and do all of that. And it's going to give us essentially a cursor that has the track ID, a year, and how much we sold of that track in that year. Then the main query that follows the parenthesis for the CTE, but this is all one unit, is going to use that CTE that we created, cursor sales by track, and I gave it a local alias of SBT, sales by track, join it to the track on the track ID, because what we're going to do here is we're going to pull the name out as well. So we're going to get the track ID, the name, the year, and the sales. And we see those results. As I say, I could have done this in one by just throwing the name in and including it in the grouping. But sometimes there are things you'd want to get that aren't as simple as that. So that's a CTE. I think you can agree it's pretty readable. You can see what's going on here. You can also include more than one CTE in a single query. So if I wanted to take those sales by track results and do something else with them, I could say comma, name of a new CTE, fields as, or I could even have something entirely separate that I also need to get the final result. Okay, but to solve the problem we're looking at now, we're going to use what's called a recursive CTE. And in a recursive CTE, that's not the right example. In the recursive CTE, it has two parts. So here, we're going to say which employee we're interested in. Here's our CTE definition, EMP hierarchy. It's going to have first name, last name, manager ID, and employee level. And what's in the CTE itself, select the first name, the last name, the reports to, and this first part, I should say, this is a union. The first part of the union is establishing what we're doing. It's setting up an initial record to work with. So we're going to initially put in the employee we're interested in, the one whose ID is 7, and we're just going to put their first name, last name, manager's ID, and 1 as the level. We're then going to union that with the interesting part of this CTE, the part where we're going to go out and we're going to take this CTE that we're building, the work in progress, join it to the employee table. On the employee's ID, employee ID, is the manager ID of the record we're looking at in the CTE we're building. This is very similar to what we did in VFP, just done in a different way. And we're going to increment the level each time through. So basically, we're going to put this first one in, and then it's going to take that first one and grab its reports to, which we've renamed manager ID, and go find that employee and stick that one in. And then we're going to go back and do that one and so on until we run out. And after we've built that, we don't really need the reports to data in our final result. So we're going to select just the first name, the last name, and the level from the CTE that we built. And not surprising, now we're doing number 7. So it'll be different results, actually. Oh, I think I left something highlighted. Let's try that again. Yeah. We started with Robert King, who's managed by Michael Mitchell, who's managed by Andrew Adams. The query is almost identical in MySQL, except that in MySQL, when you do a recursive CTE, it requires you to put the recursive keyword before the name of the CTE. Other than that, the code is identical. Okay, so this was actually in FoxPro the easier of the 2 questions. The other question we had was, given an employee, who do they manage directly and indirectly? And to do that one in VFP, you have to do more work. But pass in the idea we're interested in, and we're going to create 2 cursors. Manager hierarchy is going to hold our final results. It will include the first name and last name of the employee we're looking at now, what level they are at, and then the first name and last name of their manager. The other cursor we're going to create is employees to process, EMPs to process. These are the people who we still need to look at, because what we're going to have to do here is start with the employee of interest, grab all the people they manage, and then one by one look at those people, and grab all the people they manage and one by one look at those people, and so on until we reach the bottom of the hierarchy. So we start things off by putting into EMPs to process the employee ID that was passed in, and then first name, last name, and level 1 for the employee we're interested in. We don't know, or this person, we're not going to find out their manager. This is the person at the top of the hierarchy or sub-hierarchy that we're interested in. So we're going to start with that. And then in a loop, we're going to grab all the information we have about that person, add that person to manager hierarchy, our results cursor. Then we're going to hold on to where are we in the EMPs to process cursor, hold the recno, and then add to that cursor all of the people that this person manages. Find in employee all the people whose reports to field is the ID of the employee we're looking at right now. So it could be 0 or it could be many, many. We're going to insert them all into EMPs to process, and then we're going to go back to where we were in EMPs to process. And what's really cool is as long as I save the record pointer and restore it, Scan does not care that we're adding records to this cursor that it's scanning as we go. Anyway, then at the very end, we're just going to look at the results. So I need to pass a parameter to this, so I need to run it from the command window. And since this is such a small hierarchy, I'll just go ahead and pass in number 1, who's our main boss. And we can see Andrew Adams doesn't show a manager, but he manages Nancy Edwards and Michael Mitchell. Nancy manages the next 3. Michael manages the last 2. And if there were more, they'd keep going on down here. So that was a little more effort. In the SQL engines, it's almost identical to the last example. All we have to do is reverse the order of the join. So again, it's going to be a recursive CTE. We've added the manager name fields here, which we didn't have in the last example. And we seed it with the record we're interested in, the first one whose employee ID is EMP ID, and then we union it to all of the people. This looks very much like the last example, except that we're now grabbing the manager name because we won't know what it is. We won't know which one applies. And we've reversed the order of this join. This time it's the employees reports to is the employee ID of the one from the CTE. And then again, we're going to throw a little bit of the data that we don't need to hang on to out in the final query. And again, we get the same results we got in VFP. And the query in SQL Server is identical to this, except without the recursive keyword. So on this slide, I said the traditional way. Why did I say that? Because starting in SQL Server 2008, there is a hierarchy ID type. It's an interesting data type because it has methods, and it's built in for handling this kind of hierarchies. It encodes them in a way that lets you have multi-level hierarchies stored right in the record. Gives you some flexibility that the traditional way doesn't. I'm not going to look at the examples today, but you can answer. The truth is the code is very simple, except that it takes advantage of the capabilities that you get from the hierarchy ID type. And like the other thing I said I was not covering, actually, this is in this paper too. It's in the paper. It's in the old paper. So are there any questions?
No questions.
Okay. Then we'll go on. This is one that I hear that I've seen a lot out in the forums. If you want to get the top N by group, how do you do that? And what do I mean? Imagine that, well, say it the other way. We know how to aggregate, and we know, sorry, let me try that again. SQL Select has the top N key structure, and top N %, where you can run a query, order the results, and then keep only a subset of those results, which is great. But what if what you really want to do is you want to do some grouping, and then you want to keep the top N within each group? And the example that's on the slide is the one we're going to look at. Within each genre, what are the 5 longest tracks? And one of the reasons that we're looking at this particular piece of the result is because it shows that if there aren't 5 tracks, you'll get as many as there are. So in VFP, there are a couple of ways to do this. We're only going to look at one of them because the other is kind of a trick and has some issues. The other one is in the paper for the session. So this is another of these. Let's use SQL plus XBase. We're going to create a cursor to hold the final result, the rank, the genre name, the track name, and the track length. And then we're going to run a query just to go grab every track and its length and its genre. Put them in order by genre and then descending track length. So we now have a cursor, once we run this, that contains all of the tracks sorted by genre, and within each genre, we have them in descending order of length. Then we'll go ahead and we will grab all of the distinct genre names, which we're going to use for a loop. We're again going to do a loop. This time we're going to loop through the cursor of genres and working from the inside here. For the current genre that we're looking at, grab the top 5. We can do that. We can certainly, once we narrow it down to a single genre, just put it in descending order to keep the top 5. Then the next query out shows a nice trick, which is when you have a table, excuse me. Oh, I want to point out, by the way, this query here is a derived table. It's a query in the from clause. That's what I mean when I say derived table. You have to give it an alias, a local alias. Another nice FoxPro trick, if you have a query that involves only a single table, in this case it's a cursor, you can apply recno to rank things. So we're going to go ahead and add the recno as the rank for the records in this derived table, which are the top 5 for a given genre. And then we're going to take that and insert it into our final, our result cursor. And when I run it, we get what we expected. We're at the end. I'll go up to the top. So the 5 longest in alternative, the 5 longest in I think it's alternative and punk. I don't know. And you can see each time we've got 5 in descending track length order. As I said, there is another solution. It involves doing a really interesting join, and the more data you have, the slower it gets. So I'm not going to show it. If you're really interested, see the paper. In MySQL and SQL Server, you can use the keyword over. Over lets you do aggregation in the field list. And you see the syntax here on the slide. We'll look at that bit by bit. We won't look at it all at once. So first, we'll just look at an example with over that is not the one we're trying to solve. Here we're saying the rank function numbers things. And what we're saying is take the data we have and rank it based on the sum of the quantity in descending order. What we're going to do here is take all the genres of music and number them from sold the most to sold the fewest. So we're grouping on genre name down here. And we're going to grab the genre name. We're going to sum the number sold for that genre, joining the appropriate tables. And then we're going to put these in order by n rank. And so we see we get 1 record per genre showing the number we sold, and they're numbered sequentially. But here's an important thing. These 2 categories each sold 41 tracks. The rank function gave them the same number, which is how I was taught you rank things, that if there's a tie, they get the same number. It turns out that the SQL engines actually offer another function that lets you break that tie, not number them the same. That's the row number function. This query is identical to the one we just looked at, except it uses row number instead of rank. Row number doesn't number any 2 the same. It gives them unique numbers, which sometimes is what you want when you're numbering things. So this is the same, except the tied ones are 8 and 9. There's actually a third function because I want to go back and look at the previous example. Notice that after the 2 8s, we went right to 10. Again, that's how I was taught in school this stuff works. But there might be reasons you don't want that. There's another function, I'm not going to demonstrate it, called dense rank, that would not skip the 9. Reggae would be number 9 with that function. Okay, so we've seen that we can, by the way, the queries are the same in SQL Server, and we'll switch over there to do the next example. So using rank, I think you begin to see how we can get a hint of how we can do the top N track for track length in each genre. Once again, we're going to use a CTE. I have to say that once I learned about CTEs, I find that there are just a million uses for them once I knew they existed. So here, we're going to select the track length, the track name, the length, and the genre. And then we're going to use rank, but we're adding something inside the over. We're saying do this by first dividing up by genre ID. So take all the data, but divide it into groups by genre ID and order it in descending milliseconds, and then apply the rank function. So this time, we're going to apply the rank function separately within each genre. And I don't actually need a group by down at the bottom in this case. So the CTE is going to take all the tracks and rank them by length within genre. And then the main query says, grab all the data from that CTE, but keep only the ones where the rank field is less than or equal to 5. I gave that field the name and rank. And put them in order then by genre name and rank. So first, rank them all within their genres, and then keep only the first 5 for each genre. And here is the result that we wanted, same as in VFP. And we'll go down just to show that, yes, in fact, when we get to Opera, sure enough, there's only one because there was only one record there. So order by in a rank says what order to put the data in for selecting it. Partition by says break it up and actually apply this function only within each group rather than across the whole data set. I'll add that over has all kinds of other interesting uses. I wrote a whole paper about that. It's on my website. Are there any questions? Okay, I guess there are not questions. Okay.
No, sorry, there was one.
Oh, sorry.
Okay. So the question was actually about CTEs versus temporary tables. In MySQL and SQL Server, is the manager hierarchy table that you can query at the end similar or the same to creating a temporary table at the beginning with at?
So the table that is the CTE doesn't actually exist at the end of the whole query. It's more like a derived table. It gets created on the fly, used as needed, and then it disappears. As opposed to a temporary table, which you would create, populate, use, but then you have to clean up after yourself. Well, it's temporary, so it would go away at the end of the session, but it doesn't exist after that one query. Hope that answers the question.
And that was it.
Okay. Okay. So we've talked a lot about aggregates in this session, and we're going to keep doing so. It's really easy to aggregate data using the group by and using the aggregate functions in VFP. That's count, sum, average, min, and max. In the SQL engines, there are some additional aggregates you can do. But what's hard to do, or at least tedious to do, is what's on this slide, which is to not just do the aggregation, but then to get subtotals for the aggregates. So here, and the data, excuse me, the Chinook data is pretty sparse, so it's kind of, you don't see a good example here. But we've got a record where how many times and how much money did we sell this track for? Or this album, rather. These are albums. The artist, album, year, and month. And in theory, we'd have numbers for each month. And then how about for the whole year? How about for all years? How about for all of this artist's albums? How can we get that data along with the aggregation? And in VFP, this is a brute force problem. It's not hard, but it's brute force. So let's just start with the basic grouping, which is go in, grab the artist's name, the album title, the year and the month, total up how many tracks were sold, total up how much money that brought in, standard kind of a join, group on artist name, album title, year and month, put them in that order as well. So this is the basic data that we're going to be working with. So how do we get those totals in there? So there are three things we could do in VFP. If you only need this for output in a report, then use the report designer and use either the calculations that are built in or a set of report variables that can calculate. You don't need, you don't have to do anything in the SQL. But if you actually want the data so you can do something else with it, then you have two choices. The first is, once again, to combine SQL and XBase. So here's our original query. And then we're going to declare a whole lot of variables that are going to hold totals as we compute. We're going to create a new empty cursor to hold the results, and it's going to have the same set of fields. So I'm just going to do it with a query and make it empty and make it read-write. Chinook, all the fields are non-null, not null. So we're going to modify the artist name, album title, year and month to hold nulls. You'll see why in a minute. And then we're going to initialize all those totaling variables to 0. And we're at the top of the cursor we already created. So we're going to grab the year, album, and artist. And then we're going to do a loop. And as in so many examples of this sort, the first thing we're going to do is find out, did we get to the end of the year? And that might be that we got to the end of the year, or that we changed albums, or that we changed artists. In any of those cases, we need to report the total for this for the album we were looking at, for the year we were looking at. So we'll go ahead and add into our result cursor the artist, album, year. We'll put null for the month, and then the totals for that year. We'll now set the year variable to whatever the year is in the current record in the original cursor, and we'll zero the annual totals. But we might also have gotten to the end of this album. So we'll do the same thing at the album level if we're either on a new album or a new artist, whether or not we were on a new year. We'll add the totals for the album with nulls for the month and year. Set the CCur album variable to the one we're now looking at, and 0 the album totals. And then we'll do the third one. What if we're on a new artist? And put the artist totals in. Now we have nulls for the album, year, and month, and the totals for that artist. Update our tracking of the current artist, 0 the artist totals. After we've done all that, we're ready to deal with the current record from cursor sales, and we're just going to stick that into the result. And then we're going to add the tracks sold and the total from cursor sales to all the totals that we're tracking, the year totals, the album totals, the artist totals, and the grand totals. After the loop finishes, we're now sitting on a final record at each level, at each totaling level. So we're going to insert the annual total for the last album, all the totals for the last album, the totals for the last artist, and then the grand totals we've been computing all along the way, making all of those null. So here's what that looks like. We're at the end. Here's our grand total. Everything is null except tracks sold and total. And up here we can see, and somewhere not too far down, but I don't remember, is an example where there's more than 1 month in a year that has some data. I'm not going to go hunting for it. So that's one way we could do this. And so that the next example we'll run, we're going to close tables all and reopen the database. The second way we can do this in VFP is with by using a separate query to do the computation at each level. Here's our original query. Here's the query that computes annual totals, and we're just putting 999 in for the month. 999, so it'll sort after 12. And then the ones for the album total, where we're putting all 9s for the year and the month. And then we have one for the artist entire, when we put all Z's for the album title, again, so it'll sort at the bottom. And then the grand totals with all Z's for artist and album. And then I use union to consolidate the whole thing into one result. And yes, I could have done this as a union all the way along. I thought it was more readable this way. And then we'll order it by artist name, album title, year, and month, and put it into a cursor. Then we're going to take the same fields that we had to make nullable before and null them, make them nullable. And then we go in, and everywhere that we have the all 9s or the all Z's, we replace with a null. I needed the 9s and the Z's so things would sort in the right order. And we get the same results. I don't think that's really surprising. Okay, and we could, if we wanted, actually replace those with something meaningful, and we'll see that on the SQL side. And it's in the paper. So we're talking about this, of course, because the SQL engines give us an easier way to do this with what's called Rollup. And once again, the syntax is different in the different engines. But the notion is that we can list the fields or expressions for which we want summaries, and it will do it on a right to left basis. So first summarize for all months within a year, then summarize for a whole album across all years and months, then summarize for a whole artist across all albums, years, and months. This is the syntax in SQL Server. Down below, it's similar in MySQL. It turns out the MySQL version is a little less capable. But why don't we start with an example there, because we're going to end up spending a lot of the rest of this session in SQL Server. So here's the query to do the roll-up, to do what we just did in VFP. Get the artist name, the album title, the year, the month, how many tracks sold, how much money that was, all the appropriate joins, and then we're grouping on all those, the 4 fields we expected, and right at the bottom, at the end, we say with roll-up, meaning include all those subtotals. And here we can see, similar to what we saw in VFP. Here's one for January 2009, and here's the summary for 2009. Again, the data is very sparse, so you're not seeing multiple months before a total. And then here's the album total, and here's the artist total. Other than the syntax, it's the same in SQL Server. However, the order matters. If I pick up, for example, this album title field, and I move it to here, we're going to get a different set of summaries, because the first thing we're going to summarize on is the album across all years and months, artists, years and months, but we assume that album and artist are tightly related. And then we'll do the months, and then we'll do the years. So when we run it this way, we start out the same as we did, but then we get a different album for the same group. Then we get the total for AC/DC for January 2009, and then the total for AC/DC for all of 2009, because that was the only month there were sales. And then we come back and we do the next month that we found, which was April of 2010 for each of the albums, and then all albums for that artist for that month, and so on. So it's a very different result. So as I say, the order matters. I'm just going to put this back the way it was so I don't accidentally save it differently. In SQL Server, we can do a little more. In SQL Server, let's clean up a little. In SQL Server, we can do the same thing, but we also can leave some grouping fields out. Let's start with that. I could move artist name outside Rollup in SQL Server because it appears like a function. I can put something before it, and when I run this, I will get the rollups, the summaries on these three, but I won't get the summary that gives us the grand total at the bottom. So this all looks the same, but if I go to the bottom, whoops, down here, there's no grand total. So again, this is something you can do in SQL Server, but not MySQL because of the syntax. You also can have multiple rollups grouping things together. So this is going to do a cross product of these two. We'll do a rollup of month and year. We'll do a rollup of album and name, and then we'll do rollups across the two. So at first, it looks pretty much the same as what we'd seen until we notice that we didn't get an album total. But we did get a total for AC/DC across all albums. And there is some data further down near the bottom that's quite different. So here we have totals for the artist across months or across years, which we didn't have before. The lesson here, the key lesson, is that the way you set things up in Rollup matters a lot. You need to think about what are the totals you want to see and organize your Rollup the way you want. Also, and you can do this, as I said, in FoxPro as well, you could put meaningful names for things. You don't have to just put nulls. So in SQL Server, we do this with isNull, the built-in function that's equivalent to VFP's NVL. Evaluate the first parameter. If it's non-null, just return it. If it's null, return the second parameter. So in each case here, we're going to replace the null value with something meaningful. And we probably should have an order by here so that these come out in the right order. Yeah, but it seems to be right anyway. I think that's luck, though. So we get all these, and now it's much more readable. In MySQL, same thing, except the function is not called isNull, it's called ifNull. Does the same thing. But wait, there's more. And the rest of what I'm going to talk about here is SQL Server only. With Rollup, we were getting a specific set of summaries working from the right to the left. There's another keyword, function, I'm not really sure what to call it, cube, that says, take whatever I've listed here and give me summaries, all the combinations that you can make from what I give you. And here's our same example, which is not what was on the slide. I apologize. And now we're saying, generate all the combinations you can think of. And I just want to point out, in the last example, we had 2,613 rows in the result. when I run this one, we're going to get some things like here's a total for all albums with this name across all artists for this month. That's probably not very meaningful. And in fact, in a minute, we'll fix that. But there's all kinds of different totals. Here's for this artist and album for all Julys, for example, which actually might be an interesting piece of data. And I think if I come down far enough, somewhere in here, I'm not finding what I was looking for, but it doesn't matter. The point is we get every possible combination. And because I didn't order it, it's a little hard to find them. On the other hand, we probably should think of artist and album title as a set. While there might be different albums with the same name by different artists, we probably don't want, for example, the total for a given month for every album called Greatest Hits. So we can combine some fields in the cube. So here what we're saying, by putting parentheses around this pair of fields, we're saying treat that as one set. So we want to find all the summaries we can get that either have artist name, album title together, and then year and month separately. And when I run this one, this time we only got 3,613, and you can see we no longer have those oddball artist is null and album title is not. But we do have summaries now for everything for a month, which we didn't have before, and so forth. We also can have multiple parenthetical groups. And basically, you can do all kinds, the same as we could have two roll-ups, we can have two cubes. We're not going to look at that. Oh, except I have more time than I thought I did. We will look at that. So here I've grouped artist name and album title, and I've also grouped year and month. So we're not going to look at things like every July. We'll look at things in combination. So here's our grand total. Here's everything for January 2009 and all the other months for 2009, and then 10 and so on. And then here's everything for this album and so forth. So we've limited, we only have 1,464 rows this time. But there are still some interesting totals in here. Okay, so now these Rollup did it right to left. Cube is everything. What if you want to fine tune a little bit? Again, SQL Server only offers what are called grouping sets. Instead of letting SQL Server decide how to group, you can decide how to group. Which summaries do you want to see? And here on the slide, we're saying, give me summaries by month. So all Januaries. Give me summaries by year, all of 2010, or give me summaries for the combination of artist and album. And I'll point out, we could do this with Union. We saw that in VFP. I could just compute the summaries by month and union it with the summaries by year and union that with the summaries by artist and album, and then order it in some way that makes sense. And okay, but we can also, as I say, we have this syntax that'll do it for us. So grouping sets, this is what was on the slide. It's going to give us the exact same results as the last example. 321 rows, that's the same. Months, years, and then album, artist-album combinations. But we can list whatever we want. I want to point out also that basically, I want to talk about a syntax thing. You put each group that you want to use in parentheses. If it's in fact a single expression, the parentheses are optional. So I don't really need parentheses around month of invoice date or around year of invoice date. I do need them around artist.name, album.title. I think it's better to put them in. It makes it really clear. So once you've seen this, it becomes apparent that Rollup and Cube are special cases of grouping sets. Here's the grouping sets equivalent for the example we started with. The give us the summary by give us all the data grouped by all four, then give us the summary without the month across the year, the summary across the album, the summary across the artist, and then here we get the grand total. And this will give us what we saw in the first example of Rollup, although not ordered the same way because I didn't order it that way. And similarly, we can write cube by grouping sets. This is the cube where we had artist and album grouped and had year and month separate. The first example, or the second example we saw of cube. Same idea. We can list each grouping set that we want, and this gives us that same set of summaries. We also could omit the raw aggregates and include only the summaries. We could add the descriptions the way we did in that example with Rollup, and so forth. Are there any questions about this stuff?
This goes back a little bit, about 20 minutes or so. How can you provide free hierarchy lines by this kind of sort lines?
I'm not sure what that question means. I'm sorry.
I'm not sure either. So maybe Jörg, if you could ask that in the Q&A section.
Right. Please come to the Q&A and explain what you're thinking about.
Right. The other question is, I've implemented the group by Rollup a number of times in SQL Server and always found it to be quite slow at runtime on large data sets. I'm curious if VFP is faster, even though the logic to implement it is a bit more involved.
I don't know. I hadn't thought to test that.
Okay,
but it's a great question, and if I do this session again, I will definitely think about asking that or checking that out.
Oh, there is a follow-up here. Right. If there should be an access to sorted records by at least 10 different criteria, for example, by the country, by track title, by culture, by geographical position, by the musician links, all presented at one of the selected records, how would you implement the search criterias? Again, maybe that needs to be asked in a.
Yeah, I think I'm going to need more information about what.
Yeah, let's do that in
the Q&A
session
about
afterwards. Yeah.
Okay. Okay. Okay, so basically what we learned today is that there's a lot of stuff built in to MySQL and even more to SQL Server that isn't in VFP SQL. And while you can keep doing things the same way you've been doing them when you, well, maybe you can't actually. I was going to say, because of course, so try that again. It's a good idea to learn those ways because you'll write better code. You'll write code that's more in line with other people using SQL engines expect to see. And it may give you ideas of things you could do that you wouldn't have thought of. I'm not sure I would have thought of the Rollup stuff, doing that in queries rather than just doing it in reporting, for example. So, are there any final questions?
No.
Okay, I guess we went faster than expected, but I'm sure nobody will mind having a little bit more time. Please fill out your evaluation. They do help us get better. And thank you very much. I'll see whoever's interested over in the session room.